Assalamualaikum and hi guys. Today I will bring all of you to the lab to show you the instruments that I have taught in the class: AAS, flame and GF AAS, and then ICP-MS and ICP-OES. So let's make a visit to the lab to learn about those instruments. Let's go. Okay, Assalamualaikum and hi everyone. So we have learned about the spectroscopy instruments, right? For the spectroscopy methods, we have several instruments as I taught in the class. The first one is AAS. So this is AAS, atomic absorption spectrophotometer, and then we have AES. Actually, AES is in the analytical laboratories we no longer use AES, but just for just a purpose of learning. So I have to teach all of you about AES, but nowadays we don't use AES. Okay, so this is AES, right? We have a graphite furnace system deployed here. Okay, actually you have learned about AAS, right? We have two types of AAS: flame AAS and graphite furnace AAS. Actually, it's not two different instruments. We only have to change the compartment of the flame, right, or the graphite furnace system, right? It's the same instrument because we use the same concept. We use a source of light, spectrum, and then either flame or graphite furnace. Come on, I will show you. This is the source of the spectrum. Okay, as I told you, we have a different type of lamp for different elements. We have cadmium, nickel, copper, chromium, palladium, platinum, and so on. We have a lot of elements source of spectrum. We have EDL or HCl. Okay, either EDL or HCl type of light source, right? Different for different light source for different elements, right? So we put the holocated lamp or EDL here, and then here will be the light source coming out. Okay, for flame it will come out here, or for graphite furnace it is down there. Okay, this is the furnace. Okay, the electrothermal system. Okay, and what about the graphite tube? This is the real graphite tube. It's very small. That's why I taught in the class that we only need a small size of sample for graphite furnace system, right? So this is the graphite tube. Okay, come closer, right? So we have a hole up there. So what happened is we will put the sample automatically using the instrument inside the hole, okay, at the top of the tube, and the sample will be there and will be heat inside the electrothermal system. So now Mr. Fuad will show us how we're going to use this auto sampler for graphite furnace AS. You can see the screen now. So we completely control the graphite furnace instrument using our computer, using the system. Right now you see the camera. The camera view is inside the graphite tube. Alright, so let's go. Let us try.
Okay, before we start, we need to conditioning the tube.
What is the purpose of tube conditioning?
To remove any matrix and
interference, contaminants, and so on inside the tube. So we need to preheat the tube first, right? You can see there the temperature is increasing. After this, you can see how the instruments using the auto sampler, okay, put the sample from the sample compartment. Okay, here you can see here. Come closer. Right, we can put the sample here and program it into the computer. So the instrument, the auto sampler will automatically take the sample from the compartment and put it in the graphite tube inside the electrothermal. How you know the condition inside the graphite tube. We have a camera inside the instrument to show us what happened in the graphite tube inside the electrothermal. AS, arsenic. We're analyzing arsenic now, right? Okay.
Now we need to do some checking to see whether the graphite tube is ready for analysis, ready to use for analysis. So this is the select sample, but right now I'm using a manual selection on location. So for distilled water is 1, 2, 4.
You can see 1, 2, 4 here. Where is 1, 2, 4? Where is 1, 2, 4? There is 1, 2, 4, right? Okay, there's a number inside the sample compartment. Alright. Okay, so let us see how the auto sampler works. Okay, because we cannot put the sample manually inside the tube, so we can use only auto sampler, right? Because it's very small graphite tube. Right. This is the waste bottle. Okay. And now you can see how the auto sampler works. You can see in the camera that sample is being transferred into the tube. And then the auto sampler will flush, will clean the the capillary, okay, flush all the waste inside the waste bottle. So now is the process of heating up the sample so that the sample will vaporize inside the graphite tube. Remember, the purpose of using graphite tube is to make sure that all the sample that vaporize contained inside the tube, so that it cannot be transferred or vaporized out of the tube. Because previously, if we use flame, the easily vaporized analyte such as arsenic will vaporize outside of the flame. So that's why we use graphite furnace, so that we can let all the sample only vaporize and contain in the graphite tube, so that we can read as much as we can the percentage of the analyte. Right. Now is the process of heating up the sample and measuring the absorption. After that, we can see the absorption result here. We are not calibrating the instrument yet, Mr. Fuad. So we not calibrate the instrument yet. So we only read the absorption of the arsenic inside the water, right? Inside the distilled water. Yes, distilled water. So basically, it should be no absorption, right? But maybe a slightly interference inside the sample. So when the heating process is occur at the maximum temperature, so the camera will be off. So we can see back in the graphite tube. No more liquid drop inside the graphite tube, right? Because it's already being heated and vaporized. So now we can see the absorption here, right, the big area. Right, so this is the absorption. Okay, so basically there are no absorption, very minimal, 0.004. 0.004 is basically only about the interference inside the sample. Basically no arsenic inside the distilled water. We are not calibrating the instrument yet, so that we don't know the exact concentration. Actually, we can, after we calibrate, the calibration plot is displayed here, okay? And then we directly will know the concentration, because the instrument will refer to the calibration curve to reflect. Okay? If they read this amount of absorption, so what is the concentration? Remember, we must teach the instrument. Alright, so that is AAS. Right? Remember, as I told you, AAS is the flame or graphite furnace, is the same instrument, and we only change the compartment. This is the setup for graphite furnace, and this is the setup for flame. Okay, remember I told you, this is how the sample being pumped inside the nebulizer, and then the flame will be here. Okay, the sample will be pumped into the flame, so that the light, okay, the light source is from here. Okay, because the lamp is there, the light source will be from here. The flame will be there. Okay, the flame will be over here. Alright, and then the absorption will be measured by the detector. Okay, we have the detection set inside this compartment, right? So the instrument will measure how much the absorption occur inside the sample that have been burned in the flame. Okay, so this is the setup of graphite furnace. Okay, now so this is a really new ICP-MS that installed in our lab. So it is not ready for analyzing the sample yet, but we have installed, and we have already the first step when we install instrument. What we call it? The first step when we install instrument. Commissioning, right? Okay, we have already done the commissioning part, so this is our ICP-MS. So the plasma will be inside there. Okay, the really hot part of the instrument is the plasma, and the instrument is very sensitive. We need to have air conditioning 24/7. Okay, so this is the RAF pump to produce the plasma inside the instrument. Okay, so here we can see the plasma signal. Okay, the plasma, we can see the plasma inside there. Okay, so the sample, the concept is similar. Okay, the sample will be pumped inside the plasma, and then we have MS detector here. Okay, mass spectrometry. Okay, mass spectrophotometer inside here, and we have a quadrupole inside there. So that the quadrupole function is we will let only one atom, okay, pass through the quadrupole for one time, and the instrument will analyze what is the atom based on their mass, right? So this is ICP-MS. Now we can see the ICP-OES there. OES, okay, what is the difference between ICP, OES and ICP-MS? The detector, right? We also have a similar part of plasma here, okay? The plasma generator is here, okay? And then we have OES optical emission spectrophotometer inside here. Okay, so the instrument is slightly cheaper than SEPMS because the setup is, only we need optical emission spectrophotometer rather than mass spectrophotometer. Alright, so this instrument is also we just bought it within this year. Okay, but this is already it is ready for any analysis. We have done a lot of analysis using these instruments, right? So remember, in every instrument we have two parts, okay? The atomizer and the detector. So the atomizer is here, plasma, okay? Inductively coupled plasma. We can see the plasma inside here if the instrument is being on, right? So this is the part of detector, which is optical emission spectrophotometer. Alright, so we have a similar, we have AAS also here. Okay, the setup is for graphite furnace. Okay, one day when you are here in UTM, I will bring all of you here to see how we analyze a sample using all these instruments. Alright, let's go. Hydride Generation, AAS. So we don't need any complex atomizer using heating system like flame or electrothermal system. We only need we call as a cold vapor system, right? We just react hydrochloric acid and sodium borohydrate to produce a vapor of sample that containing our mercury analyte, and you can just detect the absorption. Okay, similar like AAS, flame AAS or graphite furnace AAS, right? But this one we don't have any heating process because mercury is easily vaporized, so that we use a cold vapor system, right? Hydride generation, okay, right? It's quite simple compared with another instrument, right? Okay, that's all from me for introduction of the instrumentations, right? See you again, bye.